So this question is the K weakness rules in a matrix. So I'm going to summarize in my own word. So you give me the metric and also integer K. So metric is either contain either 1 or 0. 1 represents soldier, 0 represents the civilian, and soldiers always position in the front of the row. So we can actually need to find out, starting from left to the middle, this is all of the soldier, and then the rest of them should be the civilian, right? So row I is weaker than row J if one of the following is true. So you want to make sure you know the constraint. So we want to return the indices of the K weakness row in the matrix. So first thing first, we need to know like how many soldier per row, right? So it's going to be 2, this is going to be 4, this is going to be 1, this is going to be 2, this is going to be 5. So if we want to return the first K weakness rows in the matrix, it's going to be this guy, K equal to 3, this guy, and this guy. So if they have the same value for the for the soldier, right, you want to know I has to be less than J, so which is going to be stored in 2, 0, 3. Alright, so how do we solve this question? Is pretty tricky. You can tell we need a soldier for sure. So soldier, something like this, and then we also need to know what is the role for the soldier, right? So soldiers has to be what, a primary key, right? So it has to be unique, and this will be what you can have multiple roles for the same soldier, right? So like this, so this has to be a list of integer, right? So this is the key, this is the value for the tree map. So tree map is actually sorted by order array, right? Then when we traverse the tree map, we can actually tell like how many K we need to stop, so how many rows we need to stop for the K the K weakness rule, right? Whatever, let's start coding and you will be follow along. So let's start it. So tree map equal to integer and list of integer, right? I'm gonna call map new tree map, and then I will traverse the map, right? So first thing first, we need to find out the ones, right? Ones equal to what? So you can actually using this, I'm going to just write down. So if v equal to 1, you add 1 else is 0, right? Or you can use in the string. So it's going to be array dot string m dot filter, and I'm going to name it x as variable, and if x equal to 1, it's going to be sum. I'm going to add the sum of them, right? So now we get all of the soldier, right? So it's going to be soldier, right? Soldier, is it how I spell it? No, I spell it wrong. Soldier, right? So we're going to initial my list if not, right? So it's going to be compute if absent, and put my soldier for the key, and then I make sure I have the array list. If I don't, I initialize it, and I add my value for the row, right? The row is represent the index, right, for I. So it would be better if you write like this: I equals 0, I less than meta length, and I plus, and then this would be mat AI, and this will be it, right? And then this, we still need a return value, right? So return value is going to be in array based on the k size, and I will return the result, right? So now I can traverse my key set, right? So key set in soldier, and then map.key set. So the weakness soldier is going to be the first one, right? Then I will have to traverse the row, like how how many how many rows for, I'm gonna say this, map.get soldier, right? And then I will just increment my index. So don't forget you need an index. So I started from 0, right? So if index is equal to k, which means we need to break it down, which means we want to return right away, right? Else we will just keep adding to what? Plus plus. So else we just append a row into the result. So let's traverse a little bit. So I build my map, right? So my map is actually considered what? Just for example 1. So my map is what? So this is gonna be what? My 2 row with my soldier 1 is row number 2 only. My 2 soldier represent my 0 and 3, and 4 soldier represent 1, 5 soldier represent 5, right? This is rules. This is soldier, right? And then I'm going to pop, I'm going to traverse. I'm going to say, oh, 2, you are the only guy. I add into your result. Okay, now I have nothing to traverse. I traverse the next one. Key set is going to be by order because it's TreeMap. I would say, oh, 0, 0. I add in, and then I add another, 1 for 3. So increment my index every single time I traverse my value, the list of integer inside my map, right? Once I hit another one, I check my index. Does my index is equal to k or not? If that is true, then I break up a value. For loop, and then return. Or I can actually do this just in case. So I can do this. If index is equal to k, I'm going to return the result. So they are the same, right? So let's look at the time and space. So this is the time. This is the time. So the worst case is going to be this one. All of m, and soldier, you traverse every single one of them. So it's going to be all of n, right? You traverse n represent column. So all of m times n, right? But we compute, right? So basically, like, it's actually sorted, right? Because TreeMap is actually log. And then this one is going to be traverse the key set. So key set is going to be all of the number of the unique element is going to be soldier, something like this. Let's look at the answer. So we're using the TreeMap and what? We're only using the TreeMap, right? So it should be like this. Yeah, it should be like this. So the time and space is all of m times n. So this is n plus log n, right? So it's going to be either like is n greater than log n, then you would just say mm. If log m is greater than n, then you say m log n. So this is the maximum either between m or log n. Alright, so this is the time, and then space is going to be all of m, right? So one of the improvements for this question is using the binary search to find out how many soldiers you have, and later on we're using the PriorityQueue using the PriorityQueue to filter like how many rows you need to have. So let's look at this. Alright, so what I need to do is what? Copy in get soldier, right? Soldier, something like this. Map, and it's gonna be what? Row, right? So I'm gonna say using the left, right, it's gonna be the last value. Well, L less than R, right? So I'm gonna create a middle value. It's gonna be L plus R minus L divided by 2, just in case. So if the mat at R at M is equal to 1, right? I know my current, current value at the middle is 1. I want to move to what? Move my L to M plus 1. I want to check, right? Does the next value is 1 or not, right? Else I will just say equal to M, right? So don't forget that this everything is based from index 0, right? So when we want to return, we need to return a soldier from base index 1, right? So if mat at I at L is equal to 1, then we say L plus 1 else L. So just think about this. So your L will be here. So I'm traversing the first row, and your L will be here, right? So you're supposed to be return 2, right? You're supposed to be return 2, but since you are here, you'll return 2 right here. But what happens if you are here? What happens if I here? This is 4, right? So mat at last row L will be 4 equal to 1. That will be 4 plus 1, right? This is base index 0. So this is 4 plus 1. Alright, enough talking. So let's start doing. So we need a priority queue. So priority queue will actually help me to sort like immediately how many soldier I have per row for the number of the k size, right? So priority queue is going to be integer pq equal to new priority queue a comma b. So I will have to sort the add the row and soldier into the priority queue. So my a will be my AB is a value inside PQ, right? But it should be the int, right? Because what I would do is I'm going to add the row comma soldier, something like this, right? Add row comma soldier. So this will be it. So if the soldier are the same, if A1 equal to B1, right? I would say okay, smallest to greatest. So it will be A0. B0 minus A0. Hold on. So if the row are the same, hold on. Let me just switch. Soldier will be the important one first. So row. So if the soldier are the same, if A0, B0, right? I'm going to say smallest to greatest for the row. Smallest is going to be A1 minus B1. Else, I'm going to say, it's going to be A0 minus B0. Smallest to greatest. If they are the same, smallest to greatest. Yeah, smaller row to greatest. Okay. So I'm traversing my map. So I guess it's going to be I equals 0, I less than mat out. Length I plus plus. So in soldier equal to get soldiers mat at what? I, right? In this row, how many soldiers I have, I will get it, right? Now is a pq.add, new int. So how many soldiers I have? I'm gonna say soldiers and then I, right? So if pq.size is actually greater than k, I can do the poll. pq.poll. So let me think about this. If I should poll, I should poll the largest one out because the smaller should remain in the PQ, right? So let's look at this. So if the soldier are the same, and I want to know is the if biggest minus smaller. So biggest row, the largest row number will be formed, and the smallest will be the least. And if not, then that will do this will be the starting. So it's going to be 0 minus A0. So sorry about this. So I'm going to make sure my greatest soldier get pulled from the PQ, not the smallest. So sorry about the mistake, but here we go. So I'm going to reassign my result in array. So it's going to be size k. So while k is greater than 0, I'm going to say result at k should be minus k, something like this, equal to pq.poll. So when I poll, I need to poll the rule. So it should be a 1, and then you should be return result. Result. Alright, so let me run it. Soldier and mat at I length. Oh, so let me represent this will be x. So this will be x, and this will be x. Oh yeah, submit. Alright, so yeah, sorry about the typo, but as you can see, like I want to make sure this is a rule, but I also use the left and right to distinguish. But this is a mistake or typo. Alright, for the time and space, yeah, this is a little bit improvement using a binary search to find a rule. So let's look at this. Binary search and PriorityQueue. So yeah, you use a binary search, you use a PriorityQueue, you sort it, yeah, this will be it, right? So the time complexity for binary search method with the PriorityQueue is m log nk, and calculation is going to be m log n, and then the size is going to be all of k. So this will be the solution. It's a little bit difficult. It shouldn't classify easy. It should classify medium, something like this, or harder. Alright, so this will be the solution, and if you have questions, leave a comment below, and I'll see you later. Bye.